Hello students, I'm Sonali Kelkar from City International School, and today we are going to do the second part of the chapter chemistry, that is acids, bases and salt. So let's start the chapter. Here in the last session we did how metals react with acid. When metal reacts with acid, hydrogen gas is evolved, and what is formed? Salt is formed. Now let's see how metal reacts with bases. Okay, it's very simple, right? When metal reacts with bases, again the salt is formed and hydrogen gas is evolved. And whether the gas is hydrogen gas or some other gas, we can test with the help of a burning splinter. If the sounds is pop-up sound comes, then definitely that is a hydrogen gas, right? Okay, so let's see the reaction first. Zinc plus sodium hydroxide. Sodium hydroxide is a base, zinc is a metal, so metal reacting with base gives us salt, right? Which salt is this? It's sodium, Na, sodium, and zincate, ZnO2 is a, this is a radical, right? Radical. So this compound is sodium zincate, and hydrogen gas is evolved here. So whenever the gas evolve, what I'm supposed to do, what we are supposed to do, you can put an arrow over here, right? Okay, so this is what happens, right? So zinc plus sodium hydroxide plus zinc gives you sodium zincate, and hydrogen gas is evolved. That you can check by bringing a burning splinter. Okay, now there is extra, this is extra, right? Extra reaction that I'm giving you here, that is sodium aluminate, is also formed by the action of sodium hydroxide. Again, I am taking the base. What is the base here? Sodium hydroxide is a base reacting with aluminium, okay, and giving us what? Sodium aluminate. Okay, there we are getting sodium aluminate. AlO2 is again a radical, which is aluminate radical, right? Sodium aluminate, and again the hydrogen gas is evolved, right? This is the extra equation. Now coming to an activity. Now let's see what is the aim of an activity. It is to show that all metal carbonates, so we are taking metal carbonates and hydrogen carbonate. Hydrogen carbonate, the short form we can say bicarbonate, right? Bicarbonate, hydrogen carbonate is one and the same thing, right? So we are taking metal carbonate, right? Can you name one or two metal carbonate? Calcium carbonate, isn't it? And sodium carbonate, right? So calcium carbonate, sodium carbonate are the example of metal carbonate, right? And sodium bicarbonate is an example of hydrogen carbonate. Okay, reacts with acids. Now we are going to react this carbonate with acid. Okay, it gives a corresponding salt. Here also we are getting a salt. So what you have to take? You have to take a test tube, okay, in which you have to take 0.5 gram of sodium carbonate, right? Sodium carbonate you have to take. Okay, then you have to add what? You have to add dilute hydrochloric acid. You have to add a dilute hydrochloric acid to this, right? There is thistle funnel, so whenever you have to add acid, make sure that you are going to add acid with a help of thistle funnel, so a drop by drop acid can be added to it. Okay, fine. Now this is a delivery tube. What we are going to collect from the delivery tube? There must be some gas which is coming out of this delivery tube, right? Now when I'm collecting this gas, okay, and into another test tube which is having calcium hydroxide, CaOH2, right? So calcium hydroxide is also known as what? It is also known as lime water. You must have heard lime water many a times, right? So when this gas is passed to lime water, this lime water is turning milky. Now can you tell me which gas is this which is evolving? Yes, this is carbon dioxide. Carbon dioxide turns lime water milky. It's very simple. Okay, so let's see the reaction. Okay, sodium carbonate, Na2CO3. Why 2? Because the valency of carbonate is 2 negative, right? Okay, so Na2CO3, CO3 won't get any because valency of sodium is 1 plus 1, so I don't have to write 1. Okay, so just Na2CO3. okay, plus HCl, hydrochloric acid, we have added. So what happened? Hydrogen is removed, right? Isn't it? Hydrogen is here, hydrogen is removed. Okay, now calcium will go and, okay, it will calcium and go and combine with chlorine. So I'm getting salt here. Sodium chloride, common salt, right? What about water? What about hydrogen? Okay, I'm getting water from hydrogen. Anyways, there are two atoms of hydrogen and one atom of oxygen is getting combined. So I'm getting water and CO2, two atoms of oxygen is remaining, right, with carbon. So carbon dioxide gas is evolved. See, we are not getting anything unique in this. Whatever we are having in this at reactant side, we are getting same on the product side, but mix and matches there, right? So this is what we get. Very important point that you should note, whenever some acids react with carbonate, okay, there is always an evolution of or evolution of carbon dioxide. Carbon dioxide is liberated, okay, wherever you find metal carbonate words, okay, react with acid, gives carbon dioxide, right? Right. Now again, as I've told you, we have to take metal carbonate and metal bicarbonate, right? So whenever you add H to this, it becomes bicarbonate or hydrogen carbonate, one and the same thing, right? Sodium bicarbonate plus HCl, right, give you NaCl as usual. Hydrogen will be removed, sodium will go and combine with chlorine. Sodium is plus, chlorine is negative. So these ions having negative charge will combine, right? What happened to HCO3? Again, as I told you, carbonate is there. So whenever you react this, whenever there is a reaction with carbonate, carbon dioxide gases evolve. What happened to hydrogen, right? These two hydrogens are remaining, right? With this hydrogen, so H2 and O, from one single O I have taken from carbonate, so H2O is formed. Simple, very simple, right? Let's go ahead. Now when I have passed this carbon dioxide gas to calcium hydroxide, that means your quick lab, right? So when I pass carbon dioxide to calcium hydroxide, what is happening? Oh my god, we are getting calcium carbonate, right? We are getting calcium carbonate, right? So we are getting calcium carbonate and water is remaining. Clear? So this is very important reaction. Fine. What happened when excess amount of carbonate gas is passed? When excess amount of carbon dioxide gas is formed, what happened? So we have already got CaCO3 plus H2O, right? Again, I'm keep on adding carbon dioxide. I'm adding carbon dioxide to it. Now what will happen? Something definitely going to change. So instead of milky solution, calcium carbonate, how is the solution? Milky, right? MILKY, milky solution, right? So what will become? It will become colorless solution of calcium hydrogen carbonate. Clear? So this is very important reactions, right? So excess amount of carbon dioxide, when it is passed, then calcium bicarbonate is formed or calcium hydrogen carbonate is formed. Okay. Yes. How do acids and base react with each other? This is a very simple reaction you are learning right from your 7th standard, right? When acids and bases react with each other, this is a strong base, this is a strong acid. Aqueous solution means you have mixed this acid with water. Okay, now how to form this acid and water solution we are going to learn very soon, right? So aqueous solution of base with water. So when you add some base with water, that bases are called alkali. Okay, that also we are going to learn, but still I am going to tell you this, right? So when base add with water, what you get? You get alkali, right? So this is sodium hydroxide, right, and HCl, both the aqueous solution. When react together, salt is formed and water is formed, right? Very common reaction and very easy reaction. This is also called neutralization reaction. Okay, the action of metal oxides with acid. Now what about the metal oxide? reacts when metal oxide react with acid, we got salt and water. Now you understood why we have learned first the neutralization reaction. Yes, we have learned first, we have taken first the neutralization reaction because this is somewhat like neutralization reaction, isn't it? Where you add acid with base, right? So you got salt and water. Here already acid is produced. Now what will be a base here? Come on, tell me what will be the base here. Can I say that metal oxide is a base here? Okay, let's see. Fine. So when I add, okay, metallic oxide react with acid to give salt and water. Now what we have taken here? We have taken copper oxide. Now copper oxide is black in color, as you can see here, right? When I add acid, that is HCl, to it, it will change into copper chloride. Now copper chloride is bluish green in color. I have already made blue color, right? So bluish green in color. And what is the extra compound which is we are getting here? Water, right? So this is very similar to neutralization reaction, isn't it? Yes, it is similar to the neutralization reaction. That is why we learned neutralization reaction before this, right? Because the presence of HCl, which is an acid, is always there. It is there, right? It is initially it is there. So I can say that copper oxide is acting like base, isn't it? So when I'm getting on my product side, when I'm getting salt and water, so it proves that copper oxide acts like a base, right? So this proves that metallic oxides are basic oxides. Metallic oxides are basic oxide. So if the question comes, how can you prove that metallic oxides are basic oxides? You have to give this reaction, dear. Okay, right? So let's take few more extra reaction. Here I have taken HCl. Over here we are taking H2SO4, right? Again aqueous solution, that is it is mixed with water, right? So copper oxide mixed with H2SO4, okay, sulfuric acids give me copper sulfate, okay, and water, right? One more, can we do one more equation? Yes, magnesium oxide, which is basic, it is basic in nature, right? Mixed with HCl gives you salt, that is magnesium chloride plus water. Okay, so let's come to the other way round. That is, here we are taking reaction of non-metallic oxide. In the previous one we took metallic oxide. Here we are taking non-metallic oxide with base. Now yes, just student here identify which is non-metallic oxide. Okay, what is calcium oxide? Is it a metallic oxide or a base? Obviously it is a base. It is a base, right? Calcium hydroxide is a base. Then what is non-metallic oxide? Of course, this is carbon dioxide. So when a non-metallic oxide reacts with base, it is still giving me the same thing. It is giving me the salt, it is giving me the water. But what is the difference here? Can you find out the difference? Yes, yes. Now here the base is already present. Okay, base is already present and carbon dioxide. And we have learned that in a neutralization reaction, base and acids give you salt and water. If base is already present, then which substance is acting as a base? If its substance is acting as an acid here. Okay, it's carbon dioxide, right? Carbon dioxide is behaving like an acid here, right? So non-metallic oxides are acidic in nature. So this proves that non-metallic oxide here, carbon dioxide, is or are acidic in nature. How you can prove? You can write this equation and prove, because at the end as a product I am getting salt and water. That means acid and bases give salt and water. So if base is already present, which the other compound is reacting like an acid here, right? That's coming. Yes, coming to this experiment. This experiment is given in your book. Okay, what do all acids and all bases have in common, right? So you must have heard that acid, if I say acid, is HCl, right? HCl, H2SO4, H2SO4, H2SO3, H2SO3, right? Have you seen something is common in these? That is hydrogen, right? So can I say that all acids have hydrogen? There is HNO3 also, H2CO3. So many acids, right? Carbonic acid, nitric acid, sulfuric acid. Okay, let me make it 4. Sulfuric acid, sulfurous acid. H2SO3 is sulfurous acid and H2SO4 is sulfuric acid, children. HCl, this is LD. Okay, so hydrochloric acid. What is common here? What we can see? It is hydrogen. So can I say that any compound which is having hydrogen is acid? Can I say that? Can I say that? Then in that case H2O is also having that. What is H2O? Water, right? Water is also having hydrogen. So is water is acid? C6H12O6 we have done, right? H12O6, what is it? Sugar. Sugar also has hydrogen. Acetic acid also has hydrogen. Glucose also, this is sugar or glucose, right? This is also has hydrogen. So can I say that these are also acid? No, 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 no. We can't say that these all are acid. So let's perform an activity which will tell you that what can be the acid, which compound can be an acid, right? Okay, so let's start. So what we are going to do, we are going to take a beaker here, right? And we are going to take an HCl over here, this beaker. There is a cork here, right? And then there is a, what is it? Yeah, this is connected to a 6-volt battery over here, and there is a bulb over here, switch over here, right? So what will happen, right? This water, and in dilute HCl means it has a content of water. Of course, it has more content of water than of HCl, right? Dilute HCl. So what happened when I pass current through it? What will happen? HCl will break down. Okay, I'll get H plus ion and Cl negative ion, H plus Al and Cl negative ion, right? This H plus ion will help in the conduction of electricity. Okay, this ion will help in the conduction of electricity. Okay, as this is plus, this is cation. Okay, all positive ions are called cations, all negative ions are called anions, right? Not anions, right? And positive are cations, right? Because they are positive, they will go to cathode, and because chlorine is negative, it will go to anode, right? So what will happen during this? Because there are ions which helps in the conduction of electricity, so my circuit will get complete, isn't it? My circuit will get complete because anyways the electricity has been passed or taken by the free ions, right? But if I put glucose and alcohol in this, is this reaction will be same? Can this bulb, will this bulb glow? No, it won't glow, right? Only in case of acid and in case of bases. Which type of base? Will it happen with NaOH? Do you think this bulb will glow if I take NaOH, dilute solution of NaOH? Yes, it will, because this will divide into OH negative, Na plus. I am getting 2 ions, right? So these ions will help in the conduction of electricity, right? So I can say that what is the concept we have learned here? That acids are those substances which dissociate in aqueous solution to form hydrogen or hydronium ions, right? Hydrogen or hydronium ions. Children, it is very, very important. Just having hydrogen doesn't make that the compound is acidic. Okay, the compound is said to be acidic when this compound in the dilute solution or in the aqueous solution. Okay, aqueous means when I mix this compound with water in that aqueous solution, okay, it is able to conduct electricity, right? It is able to dissociate and conducts electricity. How will, if it is able to dissociate, but how you are going to check whether it has dissociated or not? See, this is the experiment we did, right, to check whether the compound HCl has dissociated or not. Okay, if the bulb glow, definitely there is a dissociation of compound has divided into 2 ions, cations and anions, which help in the conduction of electricity. So in case of HCl, if I put glucose, there won't be any dissociation. This makes that the glucose and alcohols are not acid. Okay, one more thing here I want to tell you, children. Okay, if an acid completely dissociate in water, if I take a beaker, okay, and I put HCl, okay, and this HCl is completely dissociated, all each and every molecule of HCl is divided into H plus and Cl negative. So these type of acids are called strong acid. Okay, whereas if there is an incomplete dissociation, then they are called weak acid. Citric acid is an example of weak acid. HCl is example of strong acid. H2SO4 is example of strong acid. Okay, HNO3 is example of strong acid. HNO3, it should be 3, children. Okay, HNO3, right? So these are all the example of strong acid, right? Same in case of bases, right? If a base is dissolved in water, and it is not compulsory that all the base get dissolved in water. Okay, there are few bases which dissolve in water, whereas there are certain bases which doesn't dissolve in water. Okay, the bases which get dissolved in water are called alkalis, and the bases which get completely dissociate NaOH. If I take NaOH, each and every molecule of sodium hydroxide gets dissociate when I mix it in water, right? So these type of bases are strong bases. If the dissociation is incomplete, if they break down, a few molecules break down, few doesn't break down, right? That is incomplete breakdown of dissociation of alkali is there, then it is a weak base. Okay, it's very simple. Okay, fine, children. Anyway, we are going to do this concept again. Yeah, coming to the next. Yes, acids and bases conduct electricity. In the previous reaction, we have seen that acid, when mixed with water, it get dissociate, and it helps in the conduction of electricity. Now let's do the same thing in depth. This here we are going to take it with the acid as well as with base, right? Acid and base exhibit their conducting property. This is a property. Okay, acids and base has this property. This is the property, and only on the basis of this property we could able to conclude in our previous experiment whether the compound is acid or it is a base, right? So this is a peculiar property of acid, right? So what happened? Only if they are in aqueous solution. This is also very important. Another activity we are going to take with this type of concept, only in their aqueous solution, in which they could completely ionized in water, right? Okay, so an acid in water solution dissociate H plus ion. Now this H plus ion won't remain free in the solution. This H plus ion will get and combine with H2O, right? Okay, it will get and combine with H2O. I'll put positive sign here. This is the sign for combination. It will get and combine with H2O. And what are you getting here? H3O plus. What is the name of this new compound? Hydronium compounds, right? This is hydronium ion. Okay, children. So HCl in presence of water produces H plus, that is aqueous. Why I have written aqueous? Because the water presence is important, right? So H plus aqueous ion. This ion cannot exist alone and hence combine with water molecule and form hydronium. Okay, so this is a reaction which takes place when you add acid to water. Here we have taken HCl. Okay, now coming to the base. What happened in base? NaOH when mixed with water gives Na plus and OH. There should be a negative sign here. Okay, OH negative, right? Heat, why I have written heat? Because this is exothermic reaction. This is exothermic reaction. A lot of heat is produced in this reaction, right? So same with potassium hydroxide. Okay, when mixed with water gives you potassium ion, OH negative ion. Here we have done a reactivity series, right? Where K comes first and Na comes next, Kashinath, right? So K comes first and Na comes next, right? So these two, sodium and potassium, they are very, very, very reactive metals and very soft metal, right? So that is why the heat is evolved here. Clear, student? So same reaction taking place. There is a dissociation here. OH negative, that is hydroxide ion is formed. Clear? So hydrogen plus hydrogen ion and hydroxide ion contain free electrons that carries the electric charge and thereby conduct electricity. So if they ask the question why acid and base conduct electricity, in this case you need to write both the equation, okay, with proper explanation, and you have to conclude their answer with this statement. Okay, so here what you have to write, hydrogen ion and hydroxide ions contain free electron that carries electric charge and thereby conduct electricity. Okay, fine. So let's do another example. That HCl does not show acidic property in non-aqueous solution but shows acidic property in aqueous solution, right? So here what we have taken. See, aqueous solution, why the aqueous solution of HCl showing property of acidity? Why? Okay, we have done so many experiments till now, right? So let's do one more. Okay, the concept is almost same. Okay, but let's do. So what we have taken here, we have taken sodium chloride, that is salt. Okay, we have taken sodium chloride, and what we are adding here, right, we are adding here H2SO4. Sulfuric acid is slowly added to sodium chloride. Now when this is added to sodium chloride, what is happening? Some gas is liberating here. Okay, this gas is liberating here. This is nothing but chlorine gas, right? This is nothing but chlorine gas, right? So the chlorine gas, okay, what I initially did, I took a litmus paper, dry litmus paper, and kept it over here, right? So what I found, there is no change in color. There is no change in color. Okay, but next time when I dipped that litmus paper in water, okay, I took next time I took a wet blue litmus paper. This is, you can see here, moist litmus paper. How can a litmus paper be moist? Only when you put some water on it, right? So you have taken a moist litmus paper here, and then I brought it near this delivery tube. What I found here, something new, right? This start changing in color, that is, it is becoming red. Why it is becoming red? We know that blue litmus paper turns red only when the solution is acidic. But what happened when I just took a dry litmus paper? Why wasn't this reaction took place that time? Okay, let's find out the answer. It's very simple. Okay, the dry HCl does not change the color of the dry litmus paper because it does not contain hydrogen or hydronium ion. Okay, it was not containing hydrogen or hydronium ion, it was just HCl, right? The separation of hydrogen ion from HCl cannot take place in absence of water. It can only take place in the presence of water. Okay, so gas which is evolved here is HCl gas. Okay, sorry student, it was HCl gas, right? So HCl gas has evolved, but when I took a moist litmus paper, and when gas, okay, came in contact with the moist litmus paper, this immediately HCl divided into H plus and Cl negative ion, right? So this hydrogen ion, okay, this due to this hydrogen ion, which is which has all the property of acid. In fact, all all acids, okay, have their property due to this. Acids are corrosive in nature, or not all, but yeah, concentrated acid are corrosive in nature. They are sour in taste, right? They turn blue litmus red. So peculiar type of acid characteristic is just because of the presence of hydronium ion. Hydronium ion can be formed only when you mix HCl in water, right? For the previous all the experiments, we always put HCl in water, right? Okay, the same reaction took place when you dipped a litmus paper, when you took a moist litmus paper, right? So hydrogen ion is dissociated, and we saw this change in color. This experiment is very important experiment, children, and a question asked from this experiment. Right, what happened to acids and base in water? We have done this, okay, many a times, but let us do one more time. HCl and water, okay, when acts together, okay, when mixed together, what happened? Hydronium ion is formed. Yes, Cl negative. Okay, chloride ion is also formed, right? Fine, it is formed, it is not liberated. Chloride ion is also formed. Clear? Right. Bases, when dissolved in water, Bases when dissolved in water produces hydroxide ion, right? So let us consider the reaction between water and sodium hydroxide. So we have done this before, right? Water and sodium hydroxide reaction is formed where there's okay, fine. So what happened? Uh, there should be a in the previous slide, whatever reaction we did, we are supposed to write that reaction. By mistake, this reaction has been written double, right? So we have done sodium hydroxide, NaOH, okay, NaOH plus water gives you should be thorough with this now, okay. It should be sodium ion plus H hydroxide, OH ion, right? OH ion, fine. So this is what happened, clear? Now let's see the basis of neutralization reaction, how the neutralization reaction exactly takes place, right? So acid I have taken, H is a hydrogen ion, X can be chlorine, can be SO4, okay, can be HNO3, can be anything, right? Then M is a metal here, it can be sodium, it can be magnesium, it can be calcium, potassium, and OH is a hydroxide, right? So when these metal react with each other, they form salt. They form salt. So here we can see that if acid, let's take acid as HCl, right? So we have done this example in fact many a times. HCl plus NaOH, right? NaOH. So these okay, salt will form, chlorine and sodium will combine. Why chlorine and sodium combine? Still, and why chlorine and sodium combine? Chloride has a negative charge, sodium has a positive charge. So positive, negative, definitely they will combine. One is metal, one is non-metal. So metal combined with non-metal. So I am getting salt here. Okay, why? Metal combines with non-metal. This chloride is also called, one more name of chloride, radical, right? So when metals react with radical, salt is formed, and what is left? See what is left over, hydrogen and hydroxide is left over here. Okay, 2 hydrogen and 1 oxygen, isn't it? So that is why we are getting water. So this is a, it is to prove that how neutralization takes place, right? Okay, it's a very nice reaction. Caution that you are supposed to take when you make a solution, right? When you make a dilute solution of acid. Okay, first of all, so this is made under the teacher's guidance, okay, under the guidance of lab assistants. You are not supposed to do it by yourself, but even if you are doing by yourself, first you need to know that what are the chemical reaction that takes place, okay, and how you should proceed with the reaction, right? Okay. Yeah, here can you see here, this beaker is containing acid, okay, fine, and this is water. So what this boy is doing, suppose this boy is somebody, okay, like boy A, okay, what he started doing, he is mixing water to acid, right? And he's continuously stirring this, right? What his teacher told him that please don't mix water with acid. What his teacher told that mix this is a water and this is acid. His teacher told him mix acid with water and continuously stir the solution. Okay, you have to continuously stir the solution. Okay, so this is what his teacher told. He did all the way wrong, all the way opposite, vice versa. What happened? This is the result now. This is the result. And why this is the result? Okay, why this is the result? Because this is a highly exothermic reaction. Okay, when you add water to acid, this is too much of acid. too much of acid molecules are there, right? And if you are adding it, so much of heat is produced, and then if this glass is not that sturdy enough, it blasts. Okay, so this is what happened. So you should never mix water to acid. Instead of that, you should mix acid to water, and that too drop by drop, slowly and continuously. You should stir that solution, right? Why? Because whatever heat is producing, it will go off, right? Okay, it will get evolved. So because this is a exothermic reaction, if you touch the container, you will find its container is literally hot. Okay, this is what is the experiment. This is very, very important experiment. Questions can be asked from this experiment. Okay, concept inside. For answering this question, you should remember that the reaction between acid and water is an exothermic reaction, right? So water and acid is an exothermic reaction. So they can ask why the container is hot when Mohan was mixing acid to water. The container was hot. Why? Because it was an exothermic reaction, right? Coming to pH scale. pH, this is the power of hydrogen, right? Power of hydrogen. It was a potence in Germany. P stands for potence in German language, sorry. And now it is a normal language. In English we call power. So pH is nothing but the power of hydrogen, right? Now what do you mean by power of hydrogen? Okay, when the hydrogen ion, look at this, when the hydrogen ion is when the hydrogen ion is less, in fact it is more, but when you go this side, there is increase in acidity. There can be increase in acidity when the hydrogen ions are more, isn't it? Okay, so as you go on the right hand side, you see this blue is become lighter and totally gone, right? There is no blue here. So this blue color is showing that the hydrogen concentration, right? So if you move towards left, when you are moving from 7 to 0, okay, so you see that color is getting darker and darker and darker. That means hydrogen ion concentration is increasing. So whenever there is an increase in hydrogen ion concentration, that means that particular solution is very, very, very acidic, right? And let's take here 7 is a neutral. 7 is a neutral, right? Fine. 7 on the pH scale is neutral. Below 7 on pH scale, okay, is acidic, and above 7, if you go towards the 14 number, that is 7, that is a number which is greater than 7. Okay, if the pH value is more than 7, definitely that substance or that compound is basic in nature. Here if you see, the hydrogen ion concentration is increasing, right? Hydroxide ion concentration is increasing. So wherever there is a hydroxide ion concentration increases, that means that compound is more basic, right? Clear? So let's see what is written over here. pH scale ranges from 0 to 14. Yeah, this is 0 and this is 14. So the range is 0 to 14. 7 is the neutral, which is at the middle, right? Acidic solution will represent a value less than 7. Yes, we have seen that acidic are less than 7, right? And more than 7 are basic. Here we have seen that more than 7 is basic, right? When there is more than 7 means which ion concentration is more? Hydroxide ion concentration is more. When it is less than 7 means which ion concentration is more? Hydroxide ion concentration is more. It's very simple, children, right? The property of any acid, and the property of any acid is due to the presence of hydroxide ion, and the property of any basic is due to the presence of hydroxide ion, right? Property of any acid is due to the presence of hydrogen plus ion, and property of any basic is due to the presence of hydroxide ion. Clear? Okay. Now acids give rise to more hydrogen ion, H plus ion. Okay, acid give rise to more hydrogen plus ion are strong acid, whereas those give rise to less hydrogen plus ion are termed as weak acids. Clear? Similarly, bases giving rise to more hydroxide ions are strong bases, whereas those giving rise to less OH ions are termed as weak bases. The gist of this I've already told you, right? If you take a beaker, in that there is water, right, and you have put some acid, right? If this acid, let's take HCl, right? If this acid completely dissociate between hydrogen plus ion and Cl ion, chlorine ion, then definitely it has more amount of hydrogen plus ion. That means this acid is strong acids. Okay, same in case of bases, right? If you add any base to water, and each and every molecule of that base, let's take NaOH, right? Each and every molecule of NaOH, NaOH, each and every molecule of NaOH get dissociates into hydroxide ion. That means that base is strong, right? Children, you should be very careful when you're working with strong acids and strong bases. Okay, all strong acids, all strong bases are corrosive in nature, so you shouldn't touch it. You shouldn't. Okay, you should never come in directly contact with strong acids and strong bases. Okay, to avoid any accident. Fine. Now salts of strong base. Now this is very important. Strong base, and if I take two strong base, let's say compound of let's say acid and base. HCl is a strong acid and NaOH is a strong base. If I take a strong base and strong acid, then the salt, okay, that is NaCl, right? We got NaCl. Then the salt is having a pH value of 7. That means the salt is neutral, right? But if you take strong acid and weak base, right, that time the salt which is formed, it will have less than 7 pH value. That means that salt will be acidic in nature. Of course, see, strong acid and weak base, so salt will be acidic in nature, and strong base and weak acid. Okay, if you have taken very strong base and weak acid, right, in this case the nature of salt will be basic. It's very obvious, nature of the salt will be basic, right? Right, now let's see the pH scale over here. Yeah, this is usually the pH paper you get in the laboratory, right? All these, the dark red signs, color, these are acidic, right? And if you go here, this is neutral, water is neutral, pure water and blood is neutral, 7.4, right? Milk of magnesia is of 10 pH value, that means it is basic in nature. Sodium hydroxide, see, it's 14, sodium, highly basic in nature, right? Strong base, isn't it? Gastric juice 1.2, where it is present? Gastric juice is present in your stomach. It is very acidic in nature, right? Lemon juice 2.2, quite acidic in nature, right? Now let's see how does this work. Our body works within the pH range of 7.0 to 7.8. It is a very narrow range, right? And our body works in this range, right? The pH value of saliva ranges from 6.5 to 7.5. Then the pH of rainwater is less than 5.6. If the pH of rainwater is less than 5.6, we call it acid rain, right? And that lowers because of this acid rain. When this rain water go and mix with the nearby river or waterlands, then what will happen? It make that river, or it make that water resources acidic, okay? And makes it difficult for marine creatures to survive. Even the creatures which are there in rivers and ponds, it is very difficult for them to survive because of the acidic nature of water. Okay, the pH of soil optimal for the growth of plant crop is 6.5 to 7.0. That means we don't want acidic soil, right? We want basic soil, right? Which is very important for the growth of plant. Plant requires a specific pH range for their healthy growth. Okay, then coming to the stomach, right? Stomach, as you all know, it produces HCl, and you have seen that gastric juice is okay, HCl is a content of gastric juice, and which has a pH value of approximately 1.2, which is very acidic, right? But you must have occasionally suffered with acidity, right? This acidity is caused due to indigestion, right? when you eat something really heavy, very very fatty food, heavy food, spicy food, you come across this type of acidity problem, right? So it causes pain and it causes irritation, right? Due to the acidity. So doctor will always take you, he will always advise you to take magnesium hydroxide. Now what is magnesium hydroxide? The common name of magnesium hydroxide is milk of magnesia. Magnesia MgOH whole twice, right? MgOH whole twice. That is magnesium hydroxide, a mild base for offered use. This is very important, children. These question, 1 mark question can be asked on this, right? Now here bacteria present in mouth generate acid. How do bacteria present in mouth generate acid? How? Because whatever starchy food or whatever, chocolates, okay, you eat, sweets you eat, that get deposit in your gaps between the mouth, and if you don't brush it or rinse your mouth properly, what will happen? That food will be acted by bacteria, and then bacteria will definitely ferment that food and acid is formed, right? This acid will definitely going to erode your teeth, which is made up of calcium phosphate, your teeth, right? In fact, the upper part of the teeth, which we call enamel, okay, the hardest substance in your body, which is enamel and which is made up of calcium phosphate, okay. So when this acid, which is 5.5, okay, pH, which has a 5.5 pH value, acts on your calcium phosphate teeth, what will happen? It will get eroded, okay. Then you will get cavities and then pain, okay. So let's see about the stings. Okay, injects formic acid. See, formic acid and methanoic acid, which is given in your book, is same. Formic acid, methanoic acid is same. Nettle stings. Nettle is a type of plant, right? We usually call in Hindi khujli wala plant, okay. So these are the plants, okay, which has small, things like thingy. When you touch, it's really painful and very irritating, right? So again, the methanoic acid or formic acid is produced by these plants, right? So that is why you get pain, right? To get rid of this pain, what you are supposed to do? Take some soda and put it on that part where uh, this pain and irritation is existing, okay. So it will cure your problem. Then use of mild base is given here. Use of mild base like baking soda, okay, on the stung area can provide relief to some extent due to the neutralization reaction between acid and base, okay. Here we have given here, I have shown a picture of ant, okay. So this is all about today's session. Thank you so much, children, and practice what I have been taught to you. Right?